Hello and welcome to the virtual UW Milwaukee Manfred Olson Planetarium. Thank you for joining us tonight for our program Lunar Light, where we'll talk about all things moon. Before we get started, I just want to point your attention to the chat on the side or perhaps at the bottom of your page. If you think of a question during the program, you're welcome to put it in the chat. We'll have a presentation for about 20-30 minutes, and then we'll have the question and answer period where we'll answer any questions that you put in the chat. So with that, I'd like to welcome Dr. Jean Creighton, your presenter for the night.
Thank you, Victoria, and thanks everyone for joining me tonight. We are going to talk about the moon, and in all the years that I've been the planetarium director at UWM, I have found consistently that people love the moon, and it's something familiar, something they have a chance to see on numerous occasions. So it feels right to talk specifically about what makes the moon so special to us. These pictures tell a lot of the story, right? The moon is gorgeous, and it doesn't matter what phase it in, whether it's a crescent or full, it really captures the imagination. Of course, it's also a source of light. And I think for those of us who live in cities where we have so much light pollution around us, we don't really appreciate that the moon changes the way we live. However, if you live in a remote area where there are really not very many lights, or you're at sea, the moon can make a big difference in what you can and cannot do. So when the moon is full, for example, many cultures around the world still will arrange for parties, will arrange for weddings to happen on that day, because it's just naturally so much easier to get around, and it adds that beautiful glow. I mentioned already that the moon is familiar to us. Even the brightest star, even the brightest planet is basically a dot of light. The moon, however, is close enough where you can see its features. You can see some of the smooth, cool areas we call mare, from the Latin word for sea. And also these rougher areas, the highlands, that are just full of chock-a-block with scars from objects that fell on the moon. So I think this also gives us a familiarity with the moon. Now, the moon is cool also because it is part of the Earth. We think that an object about the size of Mars hit the Earth, took a chunk of the mantle off, and thanks to gravity and time, rearranged itself around the Earth. And by the way, the original impactor was destroyed. Let's see a simulation of what we think that looks like. The moon changes its appearance in a beautiful way. I'd like you to humor me. I'd like you to find a ball, and it doesn't have to be a fancy, it's better, obviously it's better if it's round, but a grapefruit and orange will do. And what I'd like you to do, even if you don't do it with me, I'd like you to try this, because so many people see the moon, admire it, but they're still not quite sure how we get the phases, why we see the moon at different times of the day, or what have you. So here's what I'd like you to do. I would like you to pretend that your head is the Earth, that the round object is the moon, and that a bright source is the sun. And I would like you to explore what I'm going to show you in a little movie in a moment so that you can see what I see. But basically what I'd like you to do is take something round and spend 5 minutes, 10 minutes with this so that forevermore you will know something about the phases of the moon. So I'd like you to take this object and make it revolve around you. To show you, I'm going to walk you through what I hope you will see for yourself with a movie that I made, not a very high-tech movie, but a movie that I made at home with an orange and that very lamp. So at this point, the orange is basically in front of me right here. So it's in front of the computer that I'm sitting at, and it is full, right? This moon is full. It means that I can see the entire illuminated, the entire lit side of the moon. Now the moon goes around the earth counterclockwise, and I'm going to start moving it to the left, and you'll start seeing that the right side of the moon is getting dark. In other words, I can't see all of the illuminated side of the moon. I'm starting to see some of the dark side. And we're getting, I overshot it. That is what we call third quarter. So half of the side we see is lit and the other half is not. The moon is what we call waning, because every day we see less of the lit side. And now my finger is going to point to you the waning crescent. There's a little bit of crescent moon there. And I parked the orange right, not exactly to block the sun, because that would be an eclipse, but this is what we call a new moon. We see none of the illuminated side, and now we have a waxing moon. So every day we're going to see a little more of the illuminated side. And we're coming close now to first quarter. And as it moves further, we use the interesting word gibbous, which means the moon is somewhere between half lit and entirely lit. And there we are with a waxing gibbous on its way to a full moon. So I'm hoping that this very low tech movie kind of helps see what these phases look like. If you have something slightly more high tech, what I would recommend is a brighter light than this one, and styrofoam balls of about 5 inches, if you happen to have one, or a white play ball is great for that. And I'm happy to discuss any aspects of phases of the moon, if you wish, later on in the question period. We found this picture and we couldn't resist it. Clearly, it was a product of love. A photographer in Italy wanted to show the phases of the moon in the sky with respect to a fixed mountain range. And it shows us that the moon is in different parts of the sky depending on its phase. And in this case, we start from the right. We're looking at a waxing crescent, and it gets to be first quarter on the lower right side. It gets bigger and bigger. This obviously doesn't happen in one night, right? We're seeing 29 different nights here. And then somewhere in the middle, we've got the full moon. It becomes a gibbous waning. It gets third quarter, and then it starts waning again as a crescent, and eventually it will be new. What I love about this picture, even though it sort of throws a lot of information at you at the same time, it reminds us that the moon is visible at different times of the day and night, depending on its phase. I can't tell you how many times people are surprised, especially young people, when you suggest that the moon is up during the day, because thanks to, songs and children's poems, we have it's daytime, the sun is up, it's nighttime, the moon is up, but the moon has a 50-50 chance of being up during the day or night. I also wanted to point out that if you're looking for a waxing crescent, then you'll have to do that in the evening, in the early evening. Whereas if you're looking for a waning crescent, you have to look much closer to the dawn. So that reminds us that moonrise and moonset are very different times of the day and night, depending on the phase. The moon changes colors. The picture that I took here, I'm sorry, I didn't take this picture. This is a picture from one of my staff, Kieran Arnold. We, as part of our welcome week for students in September this year, we had a moonwalk, and we went to the lake and we waited for the moon to rise. This was about 9 o'clock in the evening on September 2nd. And it was magical because you sit there and you look at a dark sky, and then you get a little hint of light over the water, and then it gets stronger and stronger and stronger, and you start seeing light on the lake, and poof, it comes up, and it's much redder than you'd expect. So that is a color scheme that depends on where it is in the sky. So if the moon is low, just like the sun, if the moon and the sun are low in the sky, they look redder than they would. If you're interested why, I would have you ask me. This was a beautiful occasion, and I strongly urge you, if you have an opportunity to look for a moonrise, especially if you have water to your east, then you should go for that. And of course, you can also look for a moonset if the water body is to your west. The moon also looks red during an eclipse. This image was taken by my senior producer, Nathaniel Chardine. And I thought it would be fun to show you what a lunar eclipse looks like over time. After all, it takes many hours to complete. So we're going to see it in fast forward. This particular one was from 2010. And the moon is coming into the Earth's shadow. Of course, sometimes it has no color. And this is where I've taken the orange and I've blocked the sun entirely. And I know that it's hard for me to get exactly the right angle for you to see the eclipse, but you know what I'm talking about. Sometimes, occasionally, the moon is going to be right at the right spot to block the sun. And this is a spectacular picture that shows you the corona of the sun. So this is a way of studying aspects of the sun that get completely overwhelmed when we see the main disk, the main part of the sun, what we call the photosphere. The moon is used in weird expressions, and the one that I like, of course, best is once in a blue moon, which is indeed an odd expression since the moon isn't ever blue. But it does mean that we have 2 full moons in 1 month or 4 moons in 1 season. I mean, 4 full moons. Now, this isn't, as it turns out, that infrequent. I mean, it happens every 2 or 3 years. So when you say once in a blue moon, it's not that rare. In fact, last year, perhaps you remember, on the 31st of October, we had a blue moon as well on Halloween. You do know that the moon moves water through the tides. And in fact, so much of life on our planet depends on tides. I'm going to show you a little movie from the largest tide that we see on the planet. And that's at the Bay of Fundy in Nova Scotia in Canada. things that I think is neat about the moon is that in many parts of the world, it determines calendars and it determines when feasts are going to be, when special days are holidays. And what's interesting is that depending on the symbolism, depending on the occasion, a different phase of the moon is used. So all of these can be important. Often holidays signify a beginning, so it's not surprising that the waxing crescent is used for Muharram and for Rosh Hashanah. The full moon is used for the Mid-Autumn Festival, and the full moon is often associated with harmony and peace. And for new beginnings, how could you do better than a new moon? Both the Diwali and the Lunar New Year start with the new moon. Now, of course, not only can we see the moon keep us company, we see it in a variety of ways, we can determine some of its features, but this is the only astronomical object that we've come anywhere close of stepping on, right? This is the only place we've actually been to. And I realize that many of you, of course, were alive and remember clearly Apollo 11, but of course, many of us either weren't alive or certainly were too young to remember. So I think it's nice to kind of look at this moment and enjoy it together.
30 seconds and counting. Astronauts report it feels good. T-minus 25 seconds. 20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6.
Flight controller is gonna go for landing. Retro. Go. Fido. Go. Guidance. Go. Control. Go. Telcom. Go. GNC. Go. Ecom. Go. Surgeon. Go. Capcom, we're go for landing. Altitude 4200.
You're go for landing, over. Roger, understand. Go for landing. 3,000 feet. I'm 2.5. Picking up some dust. Big shadow. 4 forward, drifting to the right a little. Houston, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
So that was certainly a magnificent moment in the history of our species, right? That we actually got to step on another whole world. The fact of the matter is that that's been 51 plus years ago, right? Just to put this in perspective, if you look at all the landings on the moon before and including 1972, most of these missions were uncrewed, right? Just machines going to the moon. And that involved, so these landings were both American and then of the Soviet Union. And of all those, only 6 involved people, right? 6 were crewed missions. And the last one was in 1972. That is the last time there's been a person on the moon. We're hoping, well, let's see how that worked out after 1972. So missions in the 80s, nope. In the 90s, neither. 2000s, nope. So in the 2010s, we've had 2 missions, Chung, I think it's called, Chinese. So one on one side of the moon, on the near side, and another one on the far side of the moon. And that's been it. And those, again, are not crewed. Those are just, I shouldn't say just, it's hard enough to send a machine to the moon, but that's what it is. We are going back, I'm happy to say. We're planning to send people back to the moon. To that end, there's a whole new project. So a whole series of missions mirroring Apollo, right? Apollo had a sister named Artemis. So Artemis 1 launches in November of 2021. This is an uncrewed mission, but it's testing the new rocket system and a new, the word has escaped my capsule, the Orion capsule. All of that's going to be tested in November. And the hope is, at least so far, the schedule seems to be still on target. 2024 Artemis 3 will be crewed. And yes, the first woman will land on the moon. Of course, we're going to celebrate and get ready. We'll have programs about the November 2021 launch. I would like, first of all, to say that I'm looking forward to your questions. I would like to thank you very much for your attention. I would like to thank Victoria Robison, without whom this whole virtual world would not be possible, and I'm very grateful to her. I'd also would like to thank the College of Letters and Science at the University of Wisconsin-Milwaukee for their support, and also the Center for Gravitation, Cosmology, and Astrophysics, also at UWM, who support the planetarium. While you're collecting your thoughts, Victoria, do we have any questions, or should I look at a couple of the questions that we had thought might be of interest?
We have a few questions. It's up to you.
Okay, well, I'll entertain a couple of things that I was thinking about, and then I'll be happy to take your questions. So what would be some of my favorite memories associated with the moon? I think I'll have to mention two, because they're sort of very specific in my career trajectory. When I was an undergraduate student, and a little fed up, to be honest, a little tired of all the things that an undergraduate has to do to graduate, I was at the University of Athens in Greece at the time. And my mother said, you know what, I think we should go to the observatory at Mount Pendeli. It took us, I think, 2 hours on the bus to get there. But they had an open night, a public night, where we got to see the moon. And I was really astonished how beautiful the moon was through a telescope. And the second moment that I had with the moon that was special was, some of you know, I spent 20 hours in the stratosphere on the largest moving observatory called Sophia. And when we landed, the moon and Venus were up, and it was such an auspicious moment. I thought, yay, even the moon is happy that our mission was so successful. So those are a couple of things that I thought might be fun to share. There were other cool things about the moon that we decided to cut out so that there's more time for your questions and I can answer to the things that you're interested in. One fun thing was that you could play a mean game of golf on the moon, since the gravity would make it possible for a golf ball to go half a mile. So that on sort of UWM, University of Wisconsin-Milwaukee terms, that's from the planetarium to Downer Woods. And another cool thing that we cut out is that because of the moon, our Earth doesn't wobble as much as it would. And that means that the climate of the Earth is much more stable, which probably has been maybe even critical for life to evolve on Earth. If we had wild swings of temperature, we can imagine it would be much harder to become the lovely creatures that we are. And with that, I will stop sharing, and I'll be happy to entertain questions that you might have.
Yeah, before I get to the questions, we have a comment saying that our low-tech moon phase video was a good visualization. So
Thank you.
glad to hear that. And Joette has the question, is it made of cheese?
No, it is not. It's mostly basalt, but that's funny.
So Rosa has asked, the moon doesn't rotate, right? Do we ever
Yes,
see
it does.
It does.
And I'm glad you asked. Now, I don't have a pre-made video for that, but I do have a fruit. So here is the exercise that I'd like you to do to convince yourself, because I can talk and talk and you won't believe me when I say it. So what I would do is, here, let me see if I can, I'm trying to find a pen that won't make a complete mess out of my hands, but let's see. So let's just say here that this is the near side of my, I don't know if you can see that, but this little grapefruit has a particular feature here, like almost like a red spot. I think you can see that because I can see it on my small screen. And this is the side that we would call the far side of the moon. The cool thing about the moon, and this is not so uncommon, by the way, is that the rate of rotation that it has is equal to the rate of revolution. So that it has to make a full circle around itself in the time that it takes to make a full circle around the Earth, which means that at the quarter of its orbit, it better have turned a quarter. And that means that effectively it will always be looking at us with the same side. So that's called a tidal lock. And as I said, it's not that uncommon among moons.
So we do not see the far side of the moon, though, because it's
We do not, that is correct. We do not see the far side of the moon. That is correct.
Okay, another question is, based on the moon rocks that were brought back during the Apollo missions, are there any valuable metals or minerals?
My understanding is that the most valuable thing the moon has is helium-3, I think it is, because it can be used for nuclear processing that involves no bad waste.
Ooh, lots more questions coming in. I lost my place. Can you explain more how the moon causes the tides?
Well, the basic idea is that the moon pulls with gravity, pulls the water on the planet. And depending on where the sun is, it can either be an additional effect, like if the sun and the moon are pulling in the same direction, then it's a more noticeable tide. And if they're pulling on opposite, then it's a less noticeable. What else can I say about that? The key point about tidal interactions is that gravity is very sensitive to distance. So if you have the moon, and I'm going to keep my hand on this side, if the moon is pulling, and I had, like, I'm solid, right? I'm the Earth, but the water responds to that more easily than the rock will. I'm sorry, I lost my train of thought there. What I was, right. So the bottom line is that the strength of the tidal force is strongly dependent on distance, even more so than gravity itself. So the tidal pull is going to be stronger on my near side of my face than the far side, which forces the water, as I said, to come toward the moon.
And a kind of a related question, is there any scientific evidence about how the moon affects us the same way that it affects the tides?
The short answer to that question, and I want you to take a deep breath because there are people who have strong opinions about this. The overwhelming evidence would suggest not. Now, having said that, I will acknowledge that we see that there are we know, for example, that some coral releases releases eggs, say for example, when there is a full moon. So we certainly have lemurs. Their menstrual cycle is connected to the moon in a much closer way, for example, than for humans. So I think for animals and maybe for people, when our lives were much more in tune with the cycles of the moon in terms of light and everything else, might have had some, maybe. I will say that I read, there was a few years ago that I really got interested in this. I thought this is a really interesting question, because I don't think I've ever met a person, especially nurses, who won't tell me, oh, full moon, crazy time at the emergency. A lot of people will say that. And I want to point out that there are two issues here. One is what we call the confirmation bias. If I have an idea, our brains are wired to look this way. We look for evidence that supports what I already think. So if, for example, I have a crazy day at the emergency room and I walk outside and I notice the moon, it's like, oh, right, it's a full moon. Of course, this place is crazy. But other days when the place is crazy and I walk outside and I don't see the moon, I don't think, oh, that's a point against me. I just don't notice that I didn't see the moon. I don't know if that makes sense. But there have been large studies about birth of babies, emergencies, suicide calls, crisis, like you name it. There's really a long list of things that people have tried to correlate with the phases of the moon. And it's not even, if there's any correlation, it's often not even that with a full moon. It can be a first quarter or some other random thing. So it's a very interesting question.
What is the goal or purpose of the upcoming Artemis missions? What do they hope to learn?
I think that we're trying to reestablish being able to. I mean, if it's been 50 years since we last sent a person to the moon, that means that there have been 2 generations of engineers who have had time to retire. So if we want to figure out, for example, how to get to Mars, going to moon is going to be a necessary step. The hope is that eventually we're going to have a base going around the moon, and that will allow us to do trips much more easily to Mars or to an asteroid.
And why haven't we been back to the moon? What has taken so long?
That's an excellent question that I'm not sure well, here's how I would answer that. The cost, and I think for many people, the going to the moon was, well, for plenty of people, it was a scientific triumph, a technological triumph, yay, yay. But for some people, and certainly for politicians, it was a political issue. And when it became clear that the Americans won the space race, then it became less interesting to continue funding at that rate. I mean, the Apollo mission was a very expensive scientific endeavor, magnificent, and it certainly brought us, microchips that you're holding in your hand, and you have a computer that's I think the phone in my hand here is 130 million times more powerful than the machines on the Apollo mission. So it certainly has interesting benefits for society.
We have a question about why was the moon red upon rising or at times during a lunar eclipse?
Okay. You give me an opportunity to use my very favorite prompt, which is a slinky. The slinky here will stand in for light. Light behaves both like a particle and a wave, but for my purposes now, it is going to behave as a wave. The distance between these 2 peaks is called a wavelength. And when the wavelengths are long, the light is a color red. And when the wavelengths are short, it's a color blue. So that's what you need to know. Now, let's say that I have some light coming in. Actually, how am I going to do this? I'm not going to be able to hold the slinky. And this is a particle in the atmosphere. And I'd like you to think, if I have blue light, which is short, and now we're going to have to pretend that this is a slinky, do you think that this particle in the atmosphere is going to block the light or not? So if this guy is coming in, do you think this is going to pose a problem for the light, or is it going to let it go through? What do you think?
I'll confess that I simply don't know.
I'm hoping you will guess.
I will guess that it will block.
Thank you.
Okay.
So it's nice to model that we're guessing, we're trying our best. Maybe we're right, maybe we're not, but it's a healthy attitude to have. Give it a shot. So yes, this will scatter. What the word is scatter. So blue light is going to come and it's going to scatter in every which direction. So if you're over here, you're actually going to see less of the blue light than you would normally. Now let's imagine that I have red light that has long wavelengths. Do you think it's going to be bothered by this thing that I'm holding, this particle in the atmosphere? Mm-hmm. Actually, I'm showing you with my hand. No, it's going to go right past it, not even notice it. It won't even notice it. Red light is going to freely come to whoever is watching this activity of light. So you're going to favor more red than blue. And that's why when things are low in the sky, or when there's been recently a volcanic eruption, or sadly last year when there were all those fires, the sunsets were gorgeous because there's much more particular matter, and that particular matter has about the same wavelength or larger than the blue light, which is why it scatters the blue light. And that's why the sky overall looks blue.
Can you talk about how the moon is slowly drifting away from Earth?
Can I talk? Some of it's well, it is. I think it's about, I think it's something like 6 to 8 centimeters a year. And one of the romantic things that people say is that eventually the moon is going to get far enough from us that we won't be able to see a total solar eclipse anymore. It will never be, its angular size will never be big enough to actually cover the sun. So it won't, I mean, first of all, this is a very gradual change, so it's not going to impact us in an immediate way.
What's the time frame for that?
Well, even at the moment when the moon is at its farthest from the Earth, it's already too small to cover the sun. But I'm talking about it will never be able to do that. So we're talking hundreds of thousands of years.
Got it.
Nothing that will happen today or tomorrow.
We have a question from Nancy Bird. Hello.
Hi, Nancy.
Twice in the past week, there have been articles about caves on the moon. Do we know for certain that such caves exist?
Do we know if caves exist? I don't know what you mean by sure. I'm assuming there have been pictures. The pictures that we get of the moon can be very high quality. If it's pictures of multiple times of day when the shadows are different, I think you can reasonably confidently say that yes, they're caves.
Two related questions. Do we know how old the Earth was when the moon broke off? And how long did it take for the moon to form after separation from Earth?
So I don't know these numbers offhand. If I had to guess, this would have happened when the solar system was still a very violent place. My guess would be in the first billion years or so of the solar system's age. And things like that to settle take millions of years.
We have another question. Is there a correlation between the moon and behavior? I think we answered that, and the short answer is
I'll give you a little bit of an interesting tidbit that I heard. I read that one of the reasons why people think now that we link the moon with lunacy, that's where the word comes from, is because in the Middle Ages, there was a particular kind of fungus on barley that made people, it was a hallucinogen.
ergo, right?
I don't remember I don't know the name, but there is one of those that is a hallucinogen. And it was when the moon was full, you could easily see these people behaving very strangely, and that's why they made the connection. This is one of the most concrete ways I've heard people try and link behavior with the moon.
Also, I'm thinking people would be out and about more.
That's right.
Yeah, during the moon. And if it's not bright out, maybe they're all just inside alone.
Right.
Hello, Sean, another super fan. I recently heard the following rumor: dinosaur bones might be on the moon. The rationale was that when the meteor hit the Earth that caused the extinction of the dinosaurs, that debris from the Earth was sent so far out that things landed on the moon, including possibly dinosaur debris. Do you think there's any potential to this idea? I hope so.
I guess. You would have to sift through a whole lot of moon rocks to find, though, the dinosaurs. We know that things have come to us all the way from Mars, so I see no reason why, in principle, there couldn't have been debris from the Earth on the moon. The nice thing about the moon is that it doesn't have an atmosphere, which means that it would preserve beautifully any debris from dinosaurs.
I see now we had lots of guesses that the short wavelength would be blocked.
Oh, very good. Yay. Yay for you. Yay.
For a minute, I forgot what this was. I was like, block? Why are they saying block so much? Okay, another question. What are the mechanics of how the moon causes the high and low tides? I think we had a question like that. Is gravity pulling the water, or is it due to the wobble of the Earth?
It is not the wobble of the Earth. It is the gravitational attraction of the moon and the sun.
Angel asks, why don't people go to any other planets except the moon?
Well, if we wanted to be technically correct, the moon is not a planet. It is what we call a natural satellite. And we are hoping to send people to Mars, but actually sending people to planets is very, very hard. As I said, we haven't sent people to the moon since 50 years have almost passed since we last did it. So it's really not easy. That's why.
Why would the moon be made up of anything different from the Earth if it was broken off of the Earth? Why would it be composed of something else?
That's an excellent question. In fact, for a long time, we were confused about the composition of the moon, because if it had just broken off from the Earth, it's too dissimilar. And if it was captured like some of the moons of Mars, then it's too similar. That's how we came up with the idea that it is a combination of an intruder. So it does bring a different composition mixed with some of the Earth.
I think we answered a version of this question, but I'll say it again. I seem to recall that the moon is either moving slowly away from Earth or getting closer. I think you said it's slowly moving away.
Slowly moving away, yeah.
Yes, okay. Can you recommend a smartphone app for better stargazing? I know there are really good ones and I can't remember the name now. But
Do we have them on our website? I thought we did.
yes, we do have a lot. We have a stargazing page on our website. I'll put the link in the chat. I know that there's lots of apps listed on that page. And do we have a time frame as to when the planetarium will reopen?
Oh, I wish.
Yeah,
I did speak. This is the hot last word. I spoke to the safety person on campus who is part of the committee who figures out, what's safe to do. And they're thinking that, depending on, they're basically like everyone, they're looking for guidance from the CDC, but I think it's possible that we might have some small programs in the summertime. And if most people are vaccinated and, COVID is definitely in remission, we're hoping to have programs in the fall. If you are a distant friend and are watching these programs virtually, I'm happy to say that we will continue some aspect of virtual programs probably until the end of the year anyway, because we have so many people who physically can't come to us even if we were open. And we love the idea that we can reach such a large audience all over the world. So we will continue some virtual programming for 2021 anyway. But we do hope to have some live programs in the planetarium where we can be under the stars together.
Let's see, Christopher asks, in the solar system, how many moons always face the same side towards their planets?
I don't have a number for that, but I would guess more than half.
That's a
It
good
is.
question. I never even thought of that.
Yeah, more than half.
Do you have any advice for someone looking to pursue their degree to study astronomy? And do you feel that this is a rewarding career?
It sure is. It sure is. Yes. Here's what you need. So I don't know what phase in your career you are right now in your schooling. But I would say you want math, of course, science. I would say computers. You should learn how to program, and Python or C++ or whatever it is that you decide, but learn at least one programming language. I find that writing, scientists spend a tremendous amount of time writing, either to get grants or to get observing time, writing papers, all of the things that you do writing, and learning another language. I would learn another language. Most scientists talk with people who speak at least 2 languages. And I think that it's just good for the brain to be able to translate, have different ways of saying the same thing. I think all of those things, frankly, would be very good for practically anything you decide to do, but it would be excellent for astronomy.
I don't see any other questions, but I do see some comments saying that people are glad that we'll continue our virtual programs. The Vislaki family is from Ohio, and their family loves our programs. So that's really nice to hear.
Yay, thank you.
So let's see. Unless anyone has any other questions, I think I got to them all, but if I didn't, you can always email us. I'll put the email in the chat. Do you have any other thoughts, Jean, that you would like to share?
I would. I think that we all have spent a little too much time indoors, a little too much time isolated and not having as much fun, I think, as we normally do. The sky offers a wonderful opportunity to look up, and the weather is getting warmer. And you can look up and sort of take in the beauty of the night sky, which you might find very rewarding and safe. You can do it outside at a distance with your loved ones and maybe your neighbors. I say, look up a little more and enjoy the night sky. Maybe go out in a dark spot and really see how the moon makes a difference in the glow of the land. And on that happy note, unless we have other questions.
I don't see any other questions.
I would like to thank you very much for joining me for Lunar Light. Again, thank you so much, Victoria, for helping with all the many technical aspects of this, and for bringing the questions to the fore, as it were. So thank you so much.
Thank you all and have a good night.